I've added a feature to our ASHRAE calculator that will allow you to use it for all of the different housing types that we weatherize. So now, in addition to using it for detached single-family housing, you can also use it for row housing and for stacked multifamily housing. This is just a quick video to show an example of how to use it for each one of those housing types. On the screen, I've just made up some inputs to show examples of each of those. And as you can see, for this first one, if this was a single-family home, I've got an ASHRAE estimate and an ASHRAE strategy that meets ASHRAE based on what I put in here. Now I want to show an example of a row house, and you'll notice when you select the row house, there's a couple of extra lines worth of information that appear here. The ASHRAE standard will allow us to have an infiltration credit on the houses that we weatherize because we're going out and we're using a blower door and we're measuring just how leaky they are. On a single family house, we get a credit for 100% of the leakiness because the house is completely detached from other homes. But on a row house, they actually want us to reduce it we only get credit for the fraction of the building envelope or the pressure boundary that is exposed to the outside. We don't get credit for the walls that adjoin the other units or that would adjoin an attached garage. So in order to calculate what that is, we need to figure out what the surface area of the adjoining or the common walls are. The surface area of all the walls on the pressure boundary and any floors or ceilings that would adjoin with a garage, and then we need to know what that remaining area is so that we can figure out what this fraction of the enclosed area compared to the rest of the house is. And when we do that, it's going to give us what I'm calling a row house multifamily multiplier, and you'll notice that it'll actually reduce the total infiltration credit. Right now, if this is a detached home, we get a credit of 57 CFM. Since this is going to be a fraction of, or it's only going to be the amount of the house that's exposed to the outside, that multiplier is going to cause this number to go down a little bit if this becomes a row house. Now, one thing to note, we're going to talk about the adjoining garage. That only applies on row houses. You don't have to start calculating this stuff for adjoining garages on a single-family house because that single-family house is not attached. It's not affected by any pressures from adjoining units, and that's why we don't have to deal with it there. But I'm going to show you how to do that for a row house here. So here I've got an example of some row housing. As a reminder, row housing means that it is connected to a bunch of units, but only connected in a row or horizontally. Each unit vertically goes from the ground to the sky. There's nothing stacked on top of or below it. If there were any units stacked above or below, then we're talking about multifamily stacked housing, and you would use the third option on the calculator. In this example, we're gonna focus on this second unit here, and just like when we're entering walls and things like that on the audit, we're talking about the pressure or the thermal boundary of this house. So I'm going to move over here to a drawing where I've drawn just the pressure boundary. Notice these houses have a garage underneath some of the living space, and that garage is not part of the pressure boundary or the thermal boundary of the house. So here in this drawing, I've drawn just the pressure boundary of each unit, and then I've pushed the units apart a little bit so that you can look down and see the common walls that are actually between the units. Now, what we need to figure out is, as the calculator shows, we need to know this total surface area of all the common walls, and then the adjoining garage, and then the remainder. So let's start with the common walls. The common walls are those walls where this unit shares a wall or is connected to the wall of this unit. So in this drawing or this example, I've colored the common walls orange. So we need to know what the surface area is of this wall plus this wall over here. And I'm using SketchUp, and when I select those walls, it will actually add up and tell me what the total surface area is there. So I've selected both of these walls, and it's telling me that the surface area in square feet of all the common walls is 1316. So we're going to go back to the calculator, and we're going to put in 1316 square feet. Now for the adjoining garage, I've colored all those walls purple here, and it's not just walls, sorry, it's also any floors or ceilings. Usually in a garage it's going to be that ceiling above, or if you were up here you'd call it a floor. But we need to know what the total surface area is of this wall, that ceiling, and then also this is an attached garage. It also has to do with any adjoining garages, and since there is a wall that our conditioned space shares with an adjoining garage, we also need to add in that surface area. So all of those combined is an area of 1,040 square feet. So we'll add that into the calculator. And then we need to know what the remaining area is, that all of the walls, attics, foundations that are exposed to the outside or are sitting on the ground or whatever. So we need to know what the surface area of all these green walls are. So I'm just going to start selecting all those, and plus the surface area of that foundation, that attic, and this back wall. So I've got all the green surfaces selected, and it's telling me that my total surface area is 2914 square feet. So we'll put that into the calculator. And the blue box just adds up all of the surface area, and again we're trying to figure out what the fraction is, or what percent of all of the total surface area is exposed to the outside. And in this case the percent is or the fraction is 0.55, or the percent is 55%. So we get 55% of our infiltration credit, because that's just the walls exposed to the outside. So 55% of that 50, what was it before? 57 would be 32 CFM. So that's what we get for an infiltration credit if this is a row house. And the calculator's set up to where whatever you put in for the final blower door, it'll calculate what your total infiltration credit is based on all of that information you put in there as well. And then, as you can see in this example, you'll have to make some adjustments in order to come up with a strategy that will meet ASHRAE. But that's how you enter in a row house. You just have to add up all the surface areas. The third type of housing is stacked housing, and the ASHRAE standard does not allow us to have an infiltration credit for stacked housing. So when you select stacked housing, you'll see that it tells you no infiltration credits allowed, and your estimated infiltration credit is 0. And it's not an error, it's because you don't get to have one per the ASHRAE standard. So again, everything adds up exactly the way it should. If this was stacked housing, it would require more ventilation, and again, you'd have to come up with a strategy that would provide that amount of ventilation. So hopefully this helps. Again, if you have any suggestions on how to improve the calculator, there's a link at the bottom where you can submit some feedback to the state. Thank you.